All right. So I guess we are earlier than the time that we the time we scheduled. It's 1:25 in my clock, but I think we can already start. Some can catch up na lang. Some are still joining, but they can catch up and review the recorded video later, siguro when we upload the video. No. So, ladies and gentlemen, I'd like to introduce to all of you Dr. Reynaldo Cruz, one of the statistics prowess, no? One of the excellent professors in statistics. No? Dr. Ray, I'm giving you now the platform for our statistics discussion. I will start sharing your PowerPoint slide, na, sir.
Yes, please. Okay, thank you very much, Dr. Alvinuki, for that very warm introduction. By the way, good afternoon to everyone. It's a great pleasure to be given the opportunity to become part of the Make Hawaiian College's Graduate School. My warm greetings, of course, to our college president, Mr. Renato Ocampo, and the members of his management staff. To our graduate school dean, who is a very good friend of mine, Dr. Francis Dice, and of course, to Dr. Alvin Nuki, research and graduate school consultant. Administrators, fellow administrators, faculty members, dear students, greetings of peace and goodwill to all of you. My assigned topic is actually inferential analysis, and you can see that on your screen. No? But let me give a brief introduction before we formally discuss inferential analysis. Statistical analysis is actually has two levels. No? Level one is oftentimes referred to as descriptive analysis of data. And level two is the inferential analysis of data. Descriptive analysis of data is conducted when the researcher would want to make a quick-hand description of a mass of quantitative data. And my friends, essentially, when we say descriptive analysis, it doesn't necessarily mean that the quantitative data will be described through words. Instead, it requires the use of appropriate descriptive statistical tests. And what are these? Can we have some kind of academic interchange, Dr. Nuki? Can some students respond?
Yes, sir. If you would like to ask them questions and if they would like to answer, yes, they can respond, sir.
Thank you very much. Okay, so I'm saying that in descriptive analysis, it doesn't mean describing the quantitative data through the use of words, but it means the use of appropriate descriptive statistical tests. Now, what are these tests, my dear co-teachers? Can anyone please speak their minds regarding this descriptive statistical test? What statistical tests could be used for in doing descriptive analysis of data? Anyone, please?
So I think Dr. Ray is inviting anyone to answer the question related to the different tests under descriptive statistics.
Or maybe I like to start the ball rolling. No? one popular cluster of descriptive statistical tests would be the use of the measures of central values, of which there are three types. No? You can guess the mean, the median, and the mode. And usually these statistical topics are used when the researcher would like to make a quick-hand description of the data, and the focus of the analysis is on the central tendency of the score. Where do the scores tend to bunch or to cluster? No? I repeat, the mean, the median, and the mode. What other tests, aside from mean, median, and mode, can be used for descriptive analysis? Anyone?
Standard deviation, sir.
Very good. That's correct. The second cluster actually, thank you, Mr. Junicia. The second cluster actually would be the measures of variability or dispersion, of which there are three types. One is the total range, second is quartile deviation, and the third is the standard deviation. On the contrary, you use the measure of variability when the researcher would like to focus on analyzing the variances or the differences of the scores, no? Kontrang-kontra sa central values. Central values, the researcher focuses on describing where the scores bunch or where the item values tend to cluster. In variabilities, the focus of analysis is how the spread of the scores, how the scores tend to disperse, or how variable are the items. Okay, so that's the second cluster. No? The third cluster could be the measures of location. So here we can use as descriptive statistical tools the percentile scores, the decile, the quintiles, the quartiles. All right? And there are many special descriptive statistical tools, like one can use skewness, and it is used when the researcher is interested to describe or to analyze the symmetry or asymmetry of the distribution, the normality or abnormality of the distributions of the item value. Or maybe you may use the kurtosis as a descriptive tool. Kurtosis focuses on analyzing the pickedness, no? The homogeneity, or the flatness, or the heterogeneity of the item values. And some other topics can also be used, like maybe we say percentage, proportions, ratios, and the like. Now, these are the descriptive statistical tests that we use in making descriptive analysis of data. On the other hand, we can ask the question, after gathering and after describing the data, what is the most logical step to do next? After gathering and describing the data using the descriptive statistical test, the most logical step to do would be to infer on the data. And this is where inferential analysis comes in. Inferential analysis comes from the root word to infer. And what does to infer mean? Anybody? What do you mean by to infer? When you infer on a set of quantitative data, what are your concerns? Can you give me one?
Good afternoon, sir.
Yes, good afternoon.
When we say to infer, sir, we are drawing valid conclusions.
Very good. That's correct. We can draw valid conclusions from the data. Any other insights? Aside from drawing valid conclusions, maybe we could also think about making sound generalization about the quantitative data. Or maybe we can come up with a logical prediction based on the given data. My dear co-teachers, two very powerful tests involving inferential analysis are correlation and regression procedures. These, my friends, are my main topic for this afternoon's lecture and maybe next Saturday. Okay? And in studying the two very powerful inferential tests, correlations and regression analysis, we shall discuss first the functions of the test. In other words, when do we use each test? We have to understand it very well, no? Because if you process your data by computer system, even if you have a computer analyst, you have to inform your computer programmer what statistical indices or values do you need. And you can draw insights from the test that you use, no? The functions of the test. Second, we will also discuss the steps in inferential analysis. Can we have slide 2, please? All right. We will discuss in the inferential process or the steps in hypothesis testing. All the inferentially statistical tests will make use of the 7 steps that you see on the board. Okay? And then later on, to amplify the discussions and to make things clear, I will present to you case studies or illustrative cases to demonstrate the applications of the test. Would that be okay with you? All right.
Yes.
So
Yes, sir.
maybe we can begin now. All right. We will begin now. Maybe we start giving you a brief discussions about the inferential process. No? I repeat, whatever inferential test is used, same steps will be observed. The process begins with, this is step 1, formulation of the hypothesis. You may notice it is plural because for every research problem, Dr. Nuki will require you to formulate a set of hypotheses. What are these hypotheses? For every research problem, 2 hypotheses will be formulated. The first is the very popular null hypothesis. And the other one would be the alternative or the research hypothesis. So take note, for every research problem that you have, you will be required to formulate a set of hypotheses. Okay, so that's the first step. No? You have to formulate your null hypothesis symbolized by an H sub O and an alternative or research hypothesis symbolized by an H sub 1. A null hypothesis is a hypothesis of no difference. It is formulated for the express purpose of being rejected. Sounds amusing. And later on, you will come to know why. It is a hypothesis formulated for the express purpose of being rejected. Okay? Usually, the null hypothesis utilizes 3 stems. The first stem is you have to use the phrase is equal to. For example, the effectiveness of method A is equal to the effectiveness of method B. So you use the phrase is equal to. The moment it is read, that means your hypothesis is null. Or you use the second stem. The second stem is no significant difference or no significant correlation exists. Okay? Kaya hypothesis of no difference. You have to use yung no significant difference. So in the case of the first example, maybe we can say no significant difference exists in the effectiveness of method A and method B in teaching mathematics. So that's an example. You can see I made use of the phrase no significant difference, and verily it qualifies as a null hypothesis. The third stem is Y is independent of X. So for example, if you are studying or analyzing teaching performance of the faculty, maybe you can come up with a null hypothesis which reads, the teaching performance is not a function of gender. Ang ating Y variable or the dependent variable is teaching performance, and our independent variable is gender. Okay, so when you say teaching performance is not a function of gender, that's a null hypothesis. And somehow you mean that the probability of becoming a good teacher is equal to both male and female. That's what I mean by Y is independent of X. So these are the 3 stems of null hypothesis. No? Is equal to, no significant difference exists, Y is independent of X. No? You can use any one of the 3. All right, for the research hypothesis, you reverse the statement. If your null hypothesis is the effectiveness of method A is equal to the effectiveness of method Y, when you go to the research hypothesis, you simply say is not. Or maybe you say method A is more effective than method Y. Or method A is less effective then may contradict mo yung null hypothesis. All right? If your null hypothesis reads no significant difference exists between method A and method B, then your research hypothesis now will read significant differences exist. Okay? To cut the long discussion short, ininegate mo yung null. Okay? Null is always no significant difference is equal to, you reverse the statement and that qualifies as an alternative or research hypothesis. Does it make sense to everybody? Any question on the hypothesis? Okay. So that is step number 1. You examine the problem and then begin by formulating a set of hypotheses. What are they again? What hypothesis will you formulate again?
Null and alternative.
Okay, null and alternative or null and research hypothesis. Thank you so much. Step number 2 would be, by the way, later on I will present to you a hypothetical case where all the steps will be shown. And that will be the time you will get a better picture of what we're talking about. Just remember the steps now. Later on, we will amplify the discussion. All right? Step number 2 is choosing the appropriate statistical test. So in this step, for step number 2, you have to make it clear what specific statistical test you will use in data analysis. And you have to give reasons or explain why you are using the test. There are many available statistical tests in the market. Now, why are you preferring, for example, the use of correlation procedure? So first, you identify what test you will use. And later, explain why the test is used. This is what we do for step number 2. I hope that's clear to the group. Step 3 says, specify the significance level and the sample size. The significance level is a choice between 0.01 and 0.05. Dalawa lang ang ginagamit natin, 0.01 and 0.05. If a researcher chooses a 0.01 level, that means he is allowing himself only 1% sampling variation for every 100 cases studied. While if the researcher chooses a 0.05, she is allowing herself a 5% sampling variation for every 100 cases studied. All right? So yung ideal level is 0.01, the pragmatic level is 0.05. For scientific, educational, and social research, both levels are accepted. Okay? So you have to specify what level of significance are you using. So you usually say, let the level of significance be, or let alpha be at 0.05, like that. And then you specify the sample size, where n equals 100. All right? I hope that's clear. It's a choice between 0.01 and 0.05, and then specify the size of your sample or the number of respondents. For significance level, I like to emphasize it's either a 0.01 or a 0.05. On a 0.01 level, the researcher allows himself one sampling variation for every 100 cases studied. In other words, observing 99% proficiency in data analysis. If the researcher chooses a 0.05, the researcher allows herself 5 sampling variations for every 100 cases handled. In other words, the researcher is trying to observe a 95% proficiency in data analysis. Okay, the next step, or step number 4, has something to do with find the sampling distribution of the test. The sampling distribution refers to the appropriate formula that has to be used. What do I mean? For example, when we talk about correlation analysis, there are about 10 correlation procedures. So when you say you are going to use a correlation analysis, what specific formula will be used? Pearson, Spearman, Phi Coefficient, biserial. Ang dami. There are 10 different types. So, i-identify ninyo which of the 10 will be used in your data analysis. Okay? That's what we mean. Sampling distribution refers to the appropriate formula of the test. The next step is specify the region of rejection. The region of rejection consists of all values more extreme than the critical value. In other words, the researcher has to locate yung critical value niya. And the critical value is a function of the alpha set and the degree of freedom or the number of cases involved in the study. Kumbaga, if you have an XY axis, you extend the lines, and where the two lines intersect, okay, you extend your vertical line, extend your horizontal line. At the point where the two lines intersect, that is what you call your critical value, or sometimes it is called the region of rejection. Better still, if your data are processed by computer system, the computer system will provide associated probabilities for every computed value, and you use that as an indicator in making decisions about your study. So usually yung region of rejection specifying if you are manipulating or computed and critical values. Pagka usually for manually computed or processed data, you use computed and critical values. That's where you use it, in region of rejection. But if your data are computerized, and that's Dr. Nuke and myself are suggesting that, to simplify matters and to save you from a lot of work, we suggest that you study very well the use of the statistical packages for social sciences, or SPSS. And that will save you from identifying so many items. Ang titingnan mo na lang ay, for every computed value, tingnan mo yung associated probability. And there is a rule that you have to apply in making the decision. For probability rules, the rule is when the associated probability of the computed value is less than alpha. The decision is for the researcher to reject the null hypothesis in favor of the research or alternative hypothesis. But if the associated probability is much higher than alpha, then the researcher has no choice but to accept the null hypothesis. Okay? And then, kung manually computed or manually generated yung data, the next step is compute the value of the test. Why are we presenting this? Because I'm sure there will be many instances where you will be asked to conduct action researches in your own school involving mga classroom-based or school-based where the data permeate easy mathematical computation. So maybe you need not use the SPSS if the data are ungrouped and the data permit easy mathematical computations. But you can compute the value of the test. In the course of our discussions, I will give you some illustrative examples about appropriate sampling distributions and how the values are computed. Finally, the last step is state the decision. There are two decision rules that you will use in making statistical decisions. Rule one is when you are using computed and critical values in your data analysis, the rule states that when the computed value is greater than the critical value, what is being compared are computed versus critical values. The rule says when the computed value is greater than the critical value, the decision is to reject the null hypothesis in favor of the alternative or the research hypothesis. Or if your data are processed by computer system using the SPSS, for example, then you use rule 2, and that is the probability rule. For every computed value or computer-generated value, there is an associated probability. what you compare is the P, the associated probability symbolized by a small p, and you will compare that with alpha. Now take note of that. Sa rule 1, what are being compared are computed value versus critical value. Sa rule 2, what you compare are associated probability values versus alpha. I repeat, sa rule 1, the rule says when the computed value is greater than the critical value, the decision is to reject the null hypothesis in favor of the research hypothesis. Sa rule 2, when the associated probability of the computed value is less than alpha, the decision is to reject the null hypothesis in favor of the research or the alternative hypothesis. Okay, I said you will get a better picture of the 7 steps as we go on with our discussion. With your permission, let me now go to the first topic of our discussions, and I'm referring to the use of correlation analysis. Can we have the next slide, please? Yes, correlations and regression procedures. Let me unlock some terms. Next slide, please. Let me begin with correlation procedure. My dear co-teachers, correlation procedure is a very powerful test. You use it when you are interested in answering or in assessing 3 basic issues. I repeat, correlation procedure is a very powerful test. You use it when you are interested to assess 3 basic issues. The first basic issue is, can we have it on screen, please? The first, okay. Is there a correlation between X and Y variables? X and Y variables may stand for any 2 variables you would like to correlate. For example, you say job satisfaction, ang X, ang Y ay teaching performance. Or maybe ang X mo is gender and Y mo is leadership ability. So X and Y may stand for any 2 variables you are correlating. Now, how do you know that a correlation exists between the variables? Let me show you a... Okay, I hope you can read this one. Can you see it? Can you read it, dear co-teachers? Kaya?
Yes, sir.
All right. How do you know that? Kasi yung first question is there a correlation between X and Y? Okay. What you have to do is compute for a correlation coefficient, the R, symbolized by a small r. This one. You have to compute this. How to compute? Huwag niyo muna in-problemahin ngayon. I'll show you later how to do it. No? But the procedure is you have to compute for the correlation coefficient symbolized by a small r. If R is 0, if R happens to be 0, that means no correlation exists between the variables and the study ends already. If R is 0. I have been in research and statistics for more than 25 years. I have not encountered a situation where R is exactly 0. Almost always, R is non-zero. Okay? It's non-zero. For as long as it is non-zero, because the coefficient may range from 0.01 to positive negative 1.00. It takes a scale of 100. All right? But whatever the number, for as long as R is non-zero, you will interpret it by saying that a correlation exists between the variables. I hope that's clear with the group. Very easy to remember, no? To answer the first question, is there a correlation between X and Y variables? To answer that, compute for the correlation coefficient or R. If R is 0, decisions nyo, no correlation exists. Okay? Now, if R is non-zero, it may be any number ranging from 0.01 to positive negative 1.00. that means a correlation exists. All right? That's easy to remember, no? If R is 0, no correlation exists. If R is non-zero, a correlation exists. Is that clear? Remember the questions because you will use them in doing your correlation analysis. Okay. Now, if there is a correlation between X and Y, you answer the second question. Next one, please. Ayan. If there is a correlation existing between the variables, you will be interested to ask the question, what kind of relationship exists? In other words, what is the nature of relationship? Again, the computed R will give you the answer. Look at this one. If R is positive, you describe the nature of relationship to be direct. In other words, the variables are directly correlated. When R is positive, you interpret it by saying direct correlation exists. And what does it mean? When you say a direct correlation exists, this is what we mean. In a direct correlation, a high value in X will go with a high value in Y, high to high. Okay? And a low value in X will go with a low value in Y. That's what you mean by a positive coefficient. Again, the computed correlation coefficient will allow you to describe the nature of relationship. The coefficient is either positive or negative. If it is positive, you interpret it by saying the variables are directly correlated, meaning the higher the value of X, the higher the value of the Y. Conversely, the lower the value of the X, the lower the value of the Y. On the other hand, if the computed coefficient is negative, you will interpret it by saying what kind of correlation exists. Pag positive, direct correlation exists. Pag negative, what? Any wild guess from the group? If a negative coefficient is derived or is obtained, we interpret it by saying X is inversely correlated with Y. And how do you explain it? You explain it by saying a higher value in X goes with a lower value in Y and vice versa. In the same vein, a lower value in X goes with a higher value in Y. Siguro to amplify matters, let me give you an example. Suppose that our X is training and Y is teaching performance. What is your hypothesis? Does the number of training correlate significantly with the level of teaching performance of the faculty? So, to answer that question, you obtain data for X, the number of trainings every teacher has, and you correlate it with their teaching performance given at the end of the year. All right? If the results happens to be positive, let us say positive 0.50, then you describe, to answer the first question, you will say, since results of the correlation analysis reveals a correlation coefficient equal to R equals 0.50, meaning non-zero, correct? So this means that training and teaching performance are correlated variables. Tapos describe natin yung nature, no? What is the nature? The nature of relationship is positive. And this means that the two variables are directly correlated. Meaning, the more trainings given to the faculty, in general, the higher the performance. The less trainings given or offered to the faculty, the lower the teaching performance. That's what we mean. Okay? Ngayon, pagka negative, inverse siya. So in a negative relationship, hindi practical na trainings and level of performance. You will make use of other variables. But that's what we mean, okay? Any question about the nature of relationship? Either positive, and you interpret it by saying the variables are directly correlated, meaning high to high and low to low ang relationship. If it is negative, you interpret it by saying the variables are inversely correlated, meaning the higher the value of the x, the lower the value of the y. The lower the value of the x, the higher the value of the y. All right. Let's go to the next issue first. All right. What is the next thing to answer is what is the degree or magnitude of relationship? There are many ways of describing the degree or magnitude of relationship. If your data are processed by computer system, the associated probability or the small p will give you will give you the insight on whether to consider the relationship significant or not. As I mentioned earlier, when p or the associated probability of the computed value is less than alpha, then you say the variables are significantly correlated. When p is less than alpha. But when p is higher than alpha, then we say the variables are non-significantly correlated. So this is the situations where you use the, actually there are two decision rules no? Regarding number 3. What is the degree of relationship? The decision rules are, I don't know if you can read it very well, but let me dictate it to you. Determine the associated, rule 1 is determine the associated probability or P of the computed value. And if P is less than alpha, the decision is to reject the null hypothesis. Otherwise, you use computed and critical values as indices. And the rule says, determine the critical value of the computed value. And if the computed value is greater than the critical value, reject the null hypothesis in favor of the research hypothesis. I'll give you a case study later, no, showing you how to do it. Okay? So at this point in time, do you understand the 3 questions? All right. I will to end the discussions of the functions. Thank you. Correlation procedure is used when the researcher is interested to assess 3 basic issues. First, the researcher would like to find out if a correlation exists between X and Y. Second, the researcher is interested to describe the nature of relationship. And third, the researchers would like to explain the degree or the magnitude of relationship. So these are the functions or the situations where correlation procedures can be used. Can we have the next slide, please? The index of correlation between variables is called a correlation coefficient. All right, so this is what we're going to compute. If you process your data by computer system like SPSS kayo, walang kahirap-hirap yan. All the computed values will come out. Sabi ko nga, for not at all times naman, it's a decided advantage if you could make use of the SPSS. But there will be some instances, like when you are doing classroom-based research or school-based research, where a software, an SPSS may not be necessary anymore. So allow me to present to you ang question na lang natin. You understand the 3 questions? Do you?
Yes po.
Okay, thank you. If
Yes,
you
sir.
understand the 3 questions, ang problem na lang natin ngayon is how to compute for the correlation coefficient or the small r that you see on screen. Okay? Now let me present to you different cases. According to Carl Pearson, the proponent of correlation procedure, there is a correlation procedure that can be used when you are working with ungrouped data. Ito yung sinasabi kong, ang number of cases ninyo, very few. When do you say data are ungrouped? Next slide, please. Okay, so this is just to differentiate correlation from regression. Okay, the correlation procedures answers the three basic questions. What is regression? Ano yan eh? Boyfriend, girlfriend yung dalawang yan. Regressions begins with correlation. And correlations is made more succinct and more interesting when you make use of regression procedures. What's the difference? So yung correlation procedure is used when you want to answer the three basic questions. Regression procedure, on the other hand, is used as a means, okay, as a means of, next one please, as a means of explaining causal relationship among variables. All right. Second, when you want to predict the value of the dependent variable based on the independent variable, yan yung x and y. Y is the y, the dependent variable is the y variable. The independent variable is your x variable. All right? Ganito kasi yung sitwasyon. When Dr. Nuki will ask you to come up with a conceptual framework, have you reached that far sa research niya? Has he presented conceptual framework? Theoretical and conceptual framework?
Yes, sir.
All right. On the left side will be your independent variables. On the right side will be your dependent variables. The independent variables would usually consist of more than one. Sometimes you have 20, sometimes you have 18, you have 15. When you do correlation analysis, the results will tell you out of 15 independent variables, how many are significantly correlated. Suppose the findings of this study tells you that out of 15 variables, only 5. All variables are correlated because you found non-zero coefficients. But only 5 were found significantly correlated. In other words, you are saying that there are 5 important explanatory factors affecting your dependent variable. So if the 5 factors are all important, your next question is, which of the 5 exerts the greatest influence? And which of the 5 exert the least influence? To answer that question, you are dealing with a cause and effect study between and among variables. So correlation cannot answer that anymore. You have to use regression analysis. In other words, regression is used when your research problem deals with causal relationship between and among variables. I hope that's clear to the group. Yung correlations, ang sinasagot lang yan is relationship. But it does not in any way tell you how much. You cannot quantify the effect of the independent variable on the dependent variable. If you like to do that, by all means, you use regression analysis. All right? And you use regressions if you want to predict the value of the dependent variable based on the independent variable. That's according to Merkler and Vanata. No? For any given x, you can predict what value would be the y, no? Using regression analysis. Next one, please. The indices of correlation analysis is a correlation coefficient symbolized by a small letter r. All right? Yun ang correlation procedure, small r. The indices of regressions are 2. The B coefficients or unstandardized coefficient, and the other one is beta coefficient. Both can be used in explaining causal relationship. What is the difference? The B coefficient is sometimes called unstandardized coefficient. And the main function is to explain what happens to y for every unit change on the x. If you increase x by one point, what happens to y? If you decrease x by 1 point, what happens to y? That's what the B coefficient explains, no? I repeat, the B coefficient explains what happens to y for every unit change in x. Okay? Ngayon, ano naman yung beta coefficient? The beta coefficient is sometimes called the standardized coefficient. If you like to compare the relative contributions of each IV to the DV, ano example ko kanina, there are 15 independent variables affecting Y. Nag-correlation analysis ka. All of them non-zero ang R. Interpretation mo? All the factors correlate with the dependent variable. I hope that's clear, no? But of the 15 variables, only 5 are significantly correlated. All right? In other words, your study revealed that there are 5 important explanatory factors. To answer the question, which of the 5 exerts the greatest influence and which of the 5 exerts the least influence, you have to standardize the coefficients. And instead of reading the B, beta, analyzing. The higher the beta, the higher the effect of the independent variable. Usually the IV that records the highest beta is the best explanatory factor for the dependent variable. Mag-i-example po tayo. Explain ko lang sa inyo what the B and the beta mean. I repeat, the B coefficient, it tells us what happens to Y for every unit increase or decrease in X. The beta coefficient is the standardized coefficient, and it explains which of the significant factors can be considered the best predictor, which of the significant factors can be considered second best, third best. You can rank. Rule, the higher the beta, the higher the effect. So this is how we differentiate correlation and regression. Simple to remember. Correlation is used when the 3 basic issues have to be answered. You go to regression when you are dealing with causal relationship between the variables. Okay? And you want to quantify how much effect does each IV variable have on the Y. We will have more examples later. Can we proceed to the next screen, please? Next slide. Ayan. So let me now illustrate. Ang problem na lang natin, if you understand what correlation procedure is, and you understand what beta regression procedure is, my concern now is to demonstrate to you how to proceed with quantifying the R, the B, and the beta. Let me begin with calculations of correlation coefficient from ungrouped data, using ungrouped data. When you say ungrouped data, you mean data less than 30. Maybe you have 10, 15, very few, such that the data permeate easy computational procedure. Okay? Please continue. The formula is not yet complete. There is a formula. Sige, I'll show you later. So, how do you end up with a table like this for correlation analysis? Definitely, when you do your thesis writing, you should have a set of respondents. Okay? A set of respondents. All right? Here, in this case, the respondents are represented by letters. Take note that the letters are from A to J, telling us that there are only 10 students involved in the study. Kaya ungrouped data ang tawag dyan, less than 30. All right? X and Y variables here stand for any 2 variables you are correlating. For example, let me say, IQ ang X, Y ang performance. Or maybe some teachers say that students who are good in mathematics are generally good in science. I don't know if you believe on that observation. So, no? If you like to test whether that is correct or not, you can do a correlation research. So, ang requirement dito, you should have a set of respondents. Right? Second, there must be valid and reliable instruments that can be used to quantify your X and Y variable. Example, if X is math, dapat meron tayong valid achievement test in mathematics. Okay? You give your valid achievement test. Di ba, at the end of the school year, bibigay kayo ng exam, final exam sa math. If that is a valid exam, then you can use it as an instrument. Or, kung may standardized instrument, better still, use it. So when you administer your math test and you score it, you write the scores of the students, opposite each name, you write the score of the student. You do the same thing with the Y, science. Dapat meron kang valid achievement test in science. All right? Administer the science test, check, or score the test, and write the scores in pair. So if you look at the table now, student A got 61 in math and 31 in science. Student B obtained 62 in X and 36 in Y and vice versa. Okay? That's what we mean by the first three columns. So do you understand where the values come from? There's the first three columns alone. All right? In computing for Pearson product moment correlation, you are required to look for summation of X. So if this is your X value, you get the sum. And the sum is 664. Can you follow? You do the same thing for the Y. Get the summation. You get a summation Y equals to 380. Okay? You are also required to have an XY summation. So what do? You multiply your X value with the Y. 61 times 31 is 1,891. 62 times 36, you have 2232. Okay? You continue that until you finish the column. And then get the summation. You get a total. Summation XY is 25,284. You are also asked to find X square summation. All right? So what do? You square every X value. 61 square or 61 times 61 is 3721. 62 times 62 is 3844. You do it for all and compute for summation X squared. So you have 44,380. Finally, you need summation Y squared. So what does it mean? You square the Y values. Student A got a score of 31 in Y. 31 times 31 or 31 square is 961. 36 square is 12. Make over yung ating screen. 1296. Then afterwards, you get the summation. Summation Y square is 14,598. My dear co-teachers, can you follow? What we need are the summation values because the formula that using Pearson for ungroup data is, next slide please. Ayan. Ayan yung formula. Kaya if you look at the table, sundan nyo na lang, no? You can try it later on. The formula is summation XY is equal to, Yes. Okay. Ang numerator is n summation xy. You will have it, yung handout natin, yung PowerPoint, i-print nyo sana. No? So you can follow. You can recheck what we are discussing. Okay? The numerator is, hindi maganda yung pagkakalagay ng ano dito. Ang numerator is n summation xy. Meron tayong summation xy kanina sa table natin. Ha? What is n? Number of cases? 10. Summation xy is 25,284. Nandun sa table natin kanina. Alright? Minus summation x times summation y. Our summation x in the table is 664. And summation y is 380. Then there is a denominator. Huh? And the denominator says from here, starting from here, square root of, I'm wondering kung ba't ganito, and the square root of n summation x square minus summation x square times n summation y square minus summation y square, and then extract the square root. If you trace it, ayun naman yung mga values, you can see that sa table. You will get a correlation coefficient equal to 0.27. So example lang, no? What do we mean by a correlation coefficient equal to 0.27? I suggest that you go back to the 3 basic issues. The first basic issue is, what is it?
There a correlation?
Very good. Is there a correlation existing between x and y? How do you give meaning to your results? If you look at the results, answerin natin, ha? Results of the correlation analysis revealed a correlation coefficient equal to 0.27 positive. This means that, halimbawa, kung yung x natin ay training, o yung x ay math, at saka yung y is science, results of the correlation analysis revealed a correlation coefficient equal to 0.27. This means that the two variables are correlated as shown by the non-zero coefficient. That is our answer for question number 1. All right? And then you proceed. The nature of relationship is, who can guess? The nature of relationship is? Look at
Directly correlated.
Positive correlation.
Mention muna natin. The nature of relationship is positive. It means that the two variables are correlated, directly correlated. Meaning, in general, the higher the math score, the higher the science score. Inversely, the lower the math score, the lower the science score. That is our answer for question number 2. Okay? Ngayon, yung next question is the magnitude or degree of relationship. Ang computed value natin is 0.27. So you compare it with the critical value. The critical value is found at the end of the stat book. Makikita niyo, table of critical R values. Kung computerized yan, the computer printout will tell you what the critical value is or what is the associated probability. Okay? Kaya halimbawa, kung ang ating, if our critical value is 0.40, sabihin natin, results of the correlation reveal a coefficient to 0.27. Since this value is less than the critical value of 0.40, this means that a correlation exists between science and math scores, but the correlation is not to a significant extent. That's how we interpret the result. Okay? Dapat masagot natin yung 3 basic correlation issues. Did I drive the point clear to you? For correlation,
Yes.
okay, ito yung Pearson product moment coefficient of correlation. You use this procedure if you are dealing with ungrouped data and the data are in the strength of interval scale, meaning quantitative yung data. What if you are dealing, bihira naman yung nag-thesis kayo on respondents nyo 10 lang. What if your respondents are more than 30? That's what Pearson is calling as group data case. So let me present to you another case. Next slide, please. Yes. Next slide, please. Oh, something is wrong with the formulas. Anyway, I have a copy of the printout. No? If you print yung ating PowerPoint, ayan, that's it. No? How does it proceed? May konting mathematical calculations ito. If you are dealing with, pero kung medyo nagulat kayo sa computation, ang dali lang, kaya lang medyo mahaba. No? Pero madali lang yung proseso. That is, kung gumagawa lang kayo ng classroom-based research and you feel SPSS is not needed anymore. Lalo na kung magaling naman kayo mag-compute. Kasi when you use the SPSS, may konting cost yan. Kasi it is a licensed software. Alright? Prepare ninyo na yung sarili nyo. Pag mapa-computerize kayo, may konting cost. But if you like to save, anyway, I can handle mathematical calculations. So, pwede kayong mag-compute. How does it proceed? You begin by identifying your respondents. No? In this case, there are 62 students participating in the research. 62, ito po siya. Yung FY at saka yung FX. Look at your FX and your FY and you will find out that there are 62 students participating. So initially, meron kayong raw data matrix. Column 1, lagay nyo doon R, respondent. You need not write the full name of the students. Maybe you can simply number them. Kung if you have 62, so number it 1 to 62. Okay? Second column, write the score in X. Okay, can you see it in our matrix? There is an X value, no? Lagyan niyo, if X is math, so write the score of the students in the math test. Next column is Y score. If that is science, write the score of the students in the science test. Is that clear? First column, number the respondents. It's not necessary that you write their full names. Second column, you write the score of the students in math. Third column, you write the scores of the students in science. Afterwards, construct a frequency distribution for the X scores. So ito po yung, if you look at our matrix, yung horizontal, yan ang frequency distribution of the X scores. Itong Y, that is the frequency distributions in science. You can find it vertically. Afterwards, summarize nyo lang yung score. Ang ibig sabihin nung FY, the next thing is itatabulate pala yung mga eskwela. In this case, there is one student who got a score of between 75 to 79 in X test, that is math. And a score between 95 to 99 in science, that is your Y. Kaya 1 ang nakalagay doon. Alright? Eh, ito naman, there is one student who got a score between 70 to 74 in the X test and a score of 90 to 94 in the Y. 2 students got a score of 75 to 79 in math, X, and between 90 to 94 in Y. That is science. Saan ang galing yan? Inulit ko, itinali natin yung mga students. The students are tallied in the cells. Yan yung distribution na itong nakikita ninyo, iyan yung tally. How many students got scores between this and between that. So, is that clear to the group? Alam nyo kung saan ang galing to? Sabi ko, dapat may matrix kayo, no? Column 1, R, respondent, 1 to 62. Column 2, score in X test, math. Column 3, score in Y test. Using yung data na yon, gagawa kayo ng matrix like this. Itatali ninyo where the students are. Alright? And you will get this. Afterwards, ito summary statistics lang. If you look at this column, first column, Y 95 to 99, there is only one student, kaya 1 siya doon. Here, you have 1 plus 2 plus 1 plus 1 plus 1, 6. You do that for all. Tapos get the sum, 62. Next step, pipili kayo ng point of origin somewhere at the center. In this case, ito ang napiling point of origin ng eskwela. Ayun. At the center, write 0. Tawagin ninyo yan na Y prime scores. At the center, at the point of origin, 0. Assign positive values above. Assign negative values below. Ganun lang kadali. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4. Okay? Dali lang, no? Mahaba lang yung proseso pero madali. Can you follow? Huh? Feedback, please. Can you follow?
Yes.
Yes. All right. Next, Fy prime. So, i-multiply nyo lang. Get the product of the Fy and the Y prime. 1 times 4 is 4. 6 times 3 is 18, and so on. Tapos, get the sum. Summation Fy prime is 4. Okay? Summation Fy prime is 4. Afterwards, yung Fy prime square, that Fy prime square, sa math kasi, when you say Y square, you mean Y times Y, no? Kaya ito, ang nakita nyo yung symbol, Fy prime square. It doesn't mean Fy prime times Fy prime. Ang ini-square natin dyan, yung Y prime lang. Kaya that means 4 times 4 is 16. 3 times 18 is 54. 2 times 18 is 36, and so on. Tapos, get the sum. The sum is 222. Medyo naka-cover lang tayo, no? Kaya hindi ko ma-explain. Yung susunod ay summation x prime. To get that, you multiply yung f times x prime. Kamukha yung first summation x prime is 0. You know, kung saan ang galing yun? Ito yung frequency, oh. The f, ang formula is f times x prime. Yung x prime nasa ibaba. Kaya yan, 1 times 0, kaya yung answer is 0. Maganda i-print nyo para masundan ninyong mabuti. No? And then, ito, marami siyang frequencies. No? So, 1 times negative 1 is negative 1. 2 times 0 is 0. 1 times 1 is 1. 1 times 3, positive 3 is 3. 1 times positive 4 is 4. And then get the sum. The sum is equal to 7. That is the procedure. All right? No? Deriving nyo na lang. The last column is summation xy. O para madali, tuturo ko na lang sa inyo shortcut. Get the product of the Fy prime times summation x prime. So in this case, 4 times 0 is 0. And then 3 times 7 is 21. 2 times 11 is 22. Then get the sum, you will get 95. Okay? Pag inisa-isa natin yan, hindi tayo tatapos. Kaya in-explain ko lang yung how to do it. Could you make some derivations when you reach home later? Pag meet pa naman tayo sa other meetings. Now, next Saturday, I suppose, we will continue. So kung may question kayo, you can jot down. And I will end sa horizontal. You will do the same thing for the vertical. And then afterwards, you use the summation values in computing for R. Slide, please. Ayun. Because this is an inferential analysis situation, magpo-formulate tayo ng hypothesis. Okay, please continue. Next one, please. Ayan yung null hypothesis natin. So in this example, X is training, and Y is performance. Get it? So look at the null hypothesis. No significant correlation exists between the level of training and performance of the employees or of the teachers. Look at that. No significant correlation. Yun yung stem natin kanina sa null. So verily, that is a null hypothesis. Ang research hypothesis natin, remove the no. No? Kumbaga, write the reverse. So ang research hypothesis natin is, the reverse of no significant correlation is significant correlation exists between the level of training and performance of the employee. Are the hypotheses clear to you? I-drop nyo lang yung no, ha? That becomes research. Okay? So let's go to the next step. Next slide, please. Next slide is, this is what I'm telling you. No? Pag nagtithesis kayo, tatanungin kayo dyan sa methodology. Usually the question is, why did you use correlation procedures and not regression? Pag gumamit kayo ng kahit anong test, pa-explain sa inyo yan. Why did you use a correlation procedure? Why not a regression procedure? To answer that, yung step number 2. So look, Pearson correlation procedure was used because the researcher would like to find out whether or not the variables are correlated, and if they are, to describe the nature and the magnitude of relationship between the variables. Where did you get the reasons from the functions of correlation kanina na ibinigay ko sa inyo? Get it? So all stat books will begin with functions of the test. Doon yung kukunin yung difference. Kaya pag tinanong kayo, why did you use correlations and not regressions? Pagdating ng oral defense, your answer is, I don't like to comment about regression. In the first place, I did not use it in my paper. But let me tell you the reasons why correlation was used. Correlation procedure was used because, ayan, present your reason. Okay? The panel members cannot force you to explain regression kung hindi mo ginamit. But if you use it, then you should be able to explain. In this example, ang ini-explain natin is the use of correlation procedure. Clear? All right, let's go to step 2, please. Next slide. Ayan. Specify the significance level, alpha, and the sample size. Ganito lang yan. They will say, let the significance level be at 0.05, where n equals 62. That's the number of cases natin, remember? Oh, very simple, no? But you should have that. Sa methodology, kailangan yan sa thesis. Step 4, please. Next slide. Ayan. Find the sampling distribution. Medyo malabo yung pagkasulat ng formula rito. But in my paper, I don't know. There is a sampling distribution. The sampling distribution is supposed to read the correlation of xy is equal to numerator. Summation of xy over n minus the mean of x times the mean of y. And then the denominator is the divided by the standard deviation of x and the standard deviation of y. Okay. Next slide, please. Step 5. Specify the region of rejection. The region of rejection consists of all values more extreme than 0.23. Saan ang galing yan? Lahat ng stat books, mayroong table of correlation coefficient at the back. Okay? Hahanapin nyo doon, titingnan nyo sa table. Hanapin nyo yung alpha. What is our alpha?
0.05.
0.05. So hanapin niyo yung 0.05 horizontal, no? Ang vertical, DF or n-1. Ang n natin is 62. So n-1 is 61. So hanapin nyo, 0.05 horizontal, 61 vertical, tapos extend the lines, no? Kung saan nyo nakita yung intersection, that is 0.23. That will not come from you. This will come from the table of correlation coefficient at the back of statistics book. Lahat ng stat books may table of R. Kung nagpa-computerize kayo, the computer printout will give you already this. Okay? So, hindi problem yan para sa inyo. Alright, let's have the next slide, please. Next slide, please. Step 6. Ayan na yung computations, no? Medyo distorted lang in presentation dito. But in my printout, it's very clear. I hope you can see it. Sana ma-print ninyo. This is what I have sent in the printouts. Something is wrong lang. Step 5, please. Step 5. Backward, one slide backward. Dr. Nuki, step 5, please. Ito yung compute the value of the test. No? Backward, please. Backward, please. Step. Anyway, ito yung estimation. Yung kanina, in-estimate yung estimation of, not yet. One more slide backward, please. Ayan. Sampling distribution. After that, you will now compute the values. Step 5 now. Can we have step 5, please? Next slide. Ayun. No? May region of rejection tayo. And then now, step 6, the computation. Compute the value of the test. Step 6 now, please. Next slide, please. Yan. Okay? Ito yung computation, and you get a correlation XY value equal to 0.42. Okay? Deriving nyo na lang, ano? I like to repeat. Pinrint ko yung ating PowerPoint. Ito siya. Very clear yung results na makikita ninyo. And you can derive where the values come from. Okay? Pag diniscuss natin isa-isa, we will not be able to finish kasi. Anyway, the procedures, may handout naman kayo. No? You can always check. And whatever questions you have, I can entertain all of them next meeting. You get a correlation coefficient equal to 0.42. Just to give you an idea again, this is a correlation study. What is our X? What is our X in our case? X value natin is level of
training.
Level of training. And our Y is performance of employees.
Teachers.
Tama ba? Performance ang Y.
Yes,
Correct? All right. And the result is a correlation coefficient equal to 0.42. You have to explain. Ang pinag-uusapan natin dito is analysis of the computed figure. Sasabihin nyo ngayon to explain the results, be reminded of the 3 issues. Sasabihin niyo, results of the correlation analysis revealed a correlation coefficient equal to positive 0.42. This means that training and performance are correlated as shown by the non-zero coefficient. Get it? Answer to question number 1. I repeat, question number 2. The nature of relationship is positive. Positive 0.42, di ba? So that means that in general, this means that the 2 variables are directly correlated. Meaning, the more trainings given to the employees, the higher their performance. Conversely, the lower the number of trainings extended to the employees, the lower their performance. Halimbawa, kung ang ating critical value ay 0.40, ang computed natin is 0.42. So that means the computed value is greater than the critical, correct? Kaya sasabihin natin, since the computed value of R equals 0.42 is greater than the critical value of 0.40, the decision is that the 2 variables are significantly correlated. Meaning, training significantly correlate with the performance of the employees. And then blah, blah, blah na lang. What does it mean? since nakita natin that training is significantly correlated, maybe you can recommend to management that the employees be given the proper training they need to be able to increase their productivity in their jobs. Okay? So, ang reminder ko sa inyo, to explain the results, answer the 3 basic questions. So, these are the 2 procedures. One is Pearson for ungrouped data, cases less than 30. The second one is Pearson group data. You use it when cases are more than 30. But whether it is ungrouped or grouped, answer the 3 basic issues. Okay? Pearson correlation coefficient is very strong if you are dealing with data that are quantitative or data in the strength of interval scale. Mga quantitative yung data. Kasi when you talk of performance, pag ang nakuha yung data is 85, 80, 75, yan yung quantitative. Kaya interval yung data. But sometimes when you gather data on performance, ang nakukuha ninyo is excellent, very satisfactory, satisfactory, fair, and poor. Correct? Umisang ganun eh. You're all teachers, is that right? Tama ba? You are teachers. Generally, the participants, you are teachers?
Yes po, Doc.
Yes.
Okay. Doon sa marking system, grading system ng DepEd, meron silang performance measures na hindi quantitative eh. Yung nakalagay doon ay excellent, tapos proficient, approaching proficiency, and did not meet expectation. Di ba parang ganun? O kaya, excellent, very satisfactory, fair, poor. If the data you are analyzing ay ganun ang nature, ang ibig sabihin, your data are categorical in strength. Therefore, you cannot use Pearson. Gagamit ka ng ibang klaseng procedures. Okay, gagamitin lang natin si Pearson if you like to answer the 3 basic questions and the data are in the strength of interval scale. Truly quantitative. So unless there are questions, we will now leave Pearson up. Kung sakali, saka yung Pearson R, it is a parametric test. Ang daming stringent assumptions. One of them, data are normally distributed or randomly selected. And the sample group must be a true representative of the population. Eh kung sa halimbawa, nagduda ng konti yung advisor mo, parang yung data mo are not normally distributed. So, you will not be allowed to use Pearson. Ano ang substitute na pwede natin gamitin? Let's go to the next test, please. Next slide, please. Yes, next one. Next slide, please. All right, ito yung decision rules na binanggit ko sa inyo kanina, no? Rule 1, if what is given is computed and critical, o kaya kung nag-manual computation kayo, ang rule na gagamitin nyo, rule 1. If the computed value is greater than the critical value, the decision is to reject the null hypothesis and conclude in favor of the research hypothesis. Pag computerized ang data, gamitin niyo yung rule 2. If the associated probability or the P of the computed value is less than alpha, reject the null hypothesis and conclude in favor of the research hypothesis. I hope that's clear to the group. Okay, let's go to the next slide, please. Okay, siguro ayan may type 1 error lang. Ano? Ang what is expected is we reject the null hypothesis when it is false. Pero iyan nagiging error ng researcher. The null hypothesis is found true pero ni-reject niya dahil gusto niyang mag-conclude in favor of his prediction. The researcher commits a type 1 error. If the researcher fails to reject the null hypothesis when in fact it is false, the researcher commits the type 2 error. Okay? Next slide, please. Ayan, mag-i-interpret na kayo. And to interpret means answering the 3 basic questions. Okay? Next slide, please. Let's go to the next. Thank you. Wala ba tayo nung Spearman's test?
Sir?
Dr. Nuki, can I show on screen yung spearman just to make them, siguro later na print out. Mukhang hindi na kasama doon sa handout ko. Is it possible to use my computer? I'll show them yung spearman.
Yes, wait lang.
Is that possible?
Yes, sir. Share screen po kayo, sir.
Yes, sir.
Share screen po kayo, sir.
Sige, check ko lang po, Doc. Nandito po ba yan? Hindi dyan. Wala. Doon sa statistics. Hold on, please. For a while.
Use meron kong isang.
Siguro, rest for a few minutes. Set up ko lang yung other test. Hindi pala nakasama yun. Ay, Doc Alvin, suyo po mag-share screen kami. Doc Ray.
Yes, naka-allow na ang share screen, sir.
Ay, sorry. Ay, sorry. Okay lang. Gawin mo yung isa. Hindi, kaya lang kumailipat eh. Doc Alvin, nasa desktop ko kasi eh.
Yes, Sir Michael.
Nasa desktop kasi yung file. Hindi ko ma-share screen. Kailangan ba?
Share screen mo tapos i-ano siya. Ano siya, PowerPoint?
Yes po. PowerPoint.
Pagka share screen mo, sige, share screen mo. I'll give you the instruction.
Yes po. Share screen.
share screen, and then i-click niyo yung PowerPoint. Ano yan, hindi pa kayo naka-share screen. I-click niyo muna yung share screen. Click share screen muna. Tapos, lalabas dyan yung desktop. Yan.
Okay.
Tapos,
Okay.
i-click niyo yung PowerPoint na gusto niyo i-open. Click,
Okay.
click the PowerPoint.
Ay, sorry. Ito po.
Yan. Click the PowerPoint yan. Open that. Open. And then, i-ano mo, play. I-ano siya.
Slideshow.
Yan. Okay, good job.
Thank you.
Okay.
Hindi nasama pala dun sa... Okay, so if the data lacks or if you're not sure that the data are not the data are doubted for normality o yung mga stringent assumptions ay hindi na-solve, ang procedure dito is to use another correlation procedures, and that will be Spearman. Spearman's rank difference correlation. Michael, dito ko na i-play. No? Ayan. The Spearman's rank difference correlation or Spearman's law is a statistics which is used to study the relationships of paired ranks. In other words, yung row scores na nakuha ninyo will be ranked first. And a correlation estimates of the degree of associations of the two sets of variables in at least an ordinary scale, so that the subjects under study may be ranked into ordered series. This commonly used test is to measure the disarray or summation d-square, where a coefficient of rank correlation is a value of +1 when the paired ranks are in similar order, or a value of -1 when the ranks are in the reverse order. Look at the examples and it will be easy to derive. Okay? To use the Spearman's rank difference score, I repeat, ang difference ng Spearman's, the data will be ranked first because it lacks the stringent requirements of normality of the scores or the distribution. So instead of analyzing the true value of the scores, you rank the scores and you analyze the ranks using this formula. The Spearman's law is equal to 1 minus summation d square over n times n square minus 1, where r square is Spearman's law, summation d square is the sum of the squared differences between ranks, and n is the number of cases. This is the procedure. I have summarized the steps. Step 1, rank the values from highest to lowest in the first set of scores, x. Do the same thing for the y. The highest value is given a rank of 1, the second 2, and so on. Step number 2, do the same thing for the y scores. Rank the scores, and then later on, give them, rank the scores and place them under r sub y column. Afterward, you get the difference, step number 3, in ranks. Step number 4, square its difference to get summation d square. And finally, sum the squared difference to find summation d square, and we apply the formula. This is very easy, a very easy test. Look at this example. Dr. Nuki, can the students hear me?
Yes, sir.
Can you hear me, dear students?
Yes.
Yes,
Yes,
sir.
sir.
In this, just to illustrate to you how the Spearman is used, there were 10 businessmen who were asked to participate in conducting a study about the correlation between capital and profit. Parang tinanong yung mga businessman, is the amount of profit a function of the amount of capital given? Alam niyo naman pagka ang study is about business, kukunti ang gustong mag-participate, baka akala taga-BIR kayo. So to complete this study of an MBA student, what the student did was at random, went to the market and select 10 businessmen who are willing to participate. Voluntarism ang ginamit. So tinanong yung businessman 1, how much capital did you pour into your business? And according to the businessman, 20,000. Wala yung isang zero. No? 20,000. How much profit was obtained?
5,000. According to the second businessman, the capital he poured in is 50,000 and generated 15,000 profit and so on. So our columns 1, 2, and 3 clear to the group. Businessman number 10 poured in 40,000 capital and generated 15,000 profit. After that, next step, no? I-rank natin, rank the X scores. What is the highest score? Highest capital? 150,000, correct? 150,000. You agree?
Yes, sir.
Okay, kaya binigyan siya ng rank 1. Second highest?
100.
100. Kaya binigyan siya ng rank 2. Third highest is 50, rank 3, and so on. Did you get the point? Assign rank 1 sa highest value up to the lowest. Okay? So these are the ranks. No, I repeat. Highest capital, 150,000, rank 1. Second highest, 100,000, rank 2. Third highest, 50,000, rank 3. Fourth highest, 40,000, rank 4, and so on. So is this clear to the group kung saan nanggaling itong rank?
Yes, sir.
Rank of X score.
Yes.
Okay, that's clear. We do the same thing for the Y. So napakadali. Highest profit generated, 70,000. Correct? Kaya rank 1 siya. Second
Yes,
highest?
sir.
Second highest?
30,000.
30,000. Kaya rank 2.
Second highest.
Okay? Next is 15,000. Dalawa yung nakakuha, no? 15 at saka 15 dito. So use 3 and 4 and get
Yes,
the
sir.
average of the rank. Kaya 3.5 and 3.5. And so on.
3.5.
Oh. Malinaw yung rank of X and rank of Y?
Yes, sir.
Okay.
Yes, sir.
Next step is find the difference between ranks. Itong D. So 6 minus 7 is negative 1. Square it, positive 1. Okay? 3 minus 3.5 is 0.5. Square it, 0.25. 9 minus 9.5 is 0.5. You square it, 0.25. Then get the summation D square, 7. Okay? Is that clear to the group?
Yes, sir. Yes.
Yes, sir.
This is the only variable that we need, summation D square, to compute for Spearman's law. Actually, napakadali nito statistics na ito. Alright? So, if you understand where 7.0 came from, next slide, please. Next slide. Sorry. Ako pala. Ayun na yung formula. Oh. This is the formula for Spearman's law. I repeat. Spearman's law is equal to 1 minus 6 times summation D square over n times n square minus 1. 1 and 6 are constant values. N is number of cases. So the only variable that we are looking at is summation D square. Can you follow? Okay.
Yes.
All right. What is our summation D square in the table?
7.0.
7.0. So here, look at it. Look at the computations now. 1 is constant, so we copy. 1 minus 6 is constant times summation D square, which is 7.0 over 10 number of respondents, no? Times 10 square minus 1. If you solve for it, you get a Spearman's law coefficient of 0.95. Isn't it very easy? Can you follow?
Yes.
Sir.
Huh? Kaya yung mga MBA students, gamit na gamit nila yan. So this is the use of results will be interpreted by answering the 3 basic questions. Okay? Cleared ba kayo dyan? Ito agreements natin, ano? We have already taken 3. Pearson and Group, Pearson Group, Spearman. when you reach home, kindly review your handouts, no? And if you have questions, write them all. Next meeting natin, before I proceed to regression, I will entertain all your questions. Okay? I like to give you time to browse the computations. Is that clear to the group? Are you amenable to that?
Yes, sir.
Okay.
Yes, sir.
I
Yes,
will give
sir.
you time to study and read, and then write your questions. I will answer them next meeting. Now let's go to another. So Pearson Ungroup and Pearson group are the appropriate correlation statistics when dealing with data in the strength of interval scale, meaning quantitative. When the data are in ranked order or the data rank normality, do not analyze the scores. Rank the values and correlate the ranks. Use, what test will you use?
Spearman.
Spearman's rank difference correlation. Very good. Now, let's go to another test. Yung kanina rin, i-open mo ili dun sa other correlation. Tingnan natin yung Phi Coefficient. Ayun, yung Phi Coefficient. All right, my dear friends, another popular correlation coefficient is the Phi Correlation Coefficient. Tandaan natin yung data. Pearson, when the data are in the strength of interval scale, quanti. Spearman's, when the data are in the strength of ordinal measurement. What about if the data are in the strength of categorical or dichotomous classification? Another correlation coefficient that you can use is the Phi Correlation Coefficient. How does it go? Let me present to you a case. Ito. A Phi Correlation Coefficient is used when the researcher would like to correlate between two real nominal dichotomous variables. Nominal na or categorical, and then dichotomous pa siya. Okay, so how does it work? Let me give you an example. A researcher is interested in finding out whether or not a correlation exists between sex and the opinion towards death penalty. Kamukha ngayon, one of the heated issues in Congress is whether to impose the death penalty or not. So is there really a correlation between the variables? There was a study conducted. X was gender or sex, and Y is death penalty. Since when we talk about gender, up to now, the category will be male and female only. Wala pa tayong transgender na kino-consider. And when we talk about, kaya categorical, no? Male or female. And dichotomous. That two and only two responses are analyzed. Why is death penalty? So when you talk about opinions, the data will be expressed in terms of in favor of death penalty or against death penalty. Correct? You agree?
Yes, sir.
All right. So you will see that both sex and death penalty are categorical or nominal dichotomous variables. Since X and Y are both nominal and dichotomous, the appropriate correlation test is Phi coefficient. All right. How does it work? Let me present to you an example. Dapat may dummy sheet muna kayo. Nakalagay doon, halimbawa, first column R, respondent. So, halimbawa, in this case, the respondent consists of...
Doc, hindi po namin makita yung slide.
Ganon? 33. You cannot see these slides?
Wala po.
Yes, sir. Hindi po.
Hindi po makita.
Sandali lang.
Wala po, sir.
Okay. Yes, Meron na?
Wala pa po.
Wala pa rin. Stop.
Wala pa po, sir.
Okay, in a few minutes, please.
Sir, mag-share screen kayo.
Yes po.
Ray, mag-share screen po.
Yes, yes. We're doing that now.
Ayan, sir, okay na po.
Okay na? Thank you. All right. So ito yung illustrative case, no? A researcher is interested in finding out whether or not a correlation exists between sex and the opinion towards death penalty Y. Since X and Y are both nominal dichotomous variables, the appropriate test is the Phi coefficient. How does it work? Let me present to you an example. I am saying that before you do the analysis for the computations, you should have at least a matrix. Column 1, again, si Kambukari sa Pearson, are respondents. All right? Number them, 1 to 33, like that. Tapos, X, enter your, ang X natin is gender. So your entry should either be male or female. Can you follow? Halimbawa, respondent number 1, male. Ganyan. Respondent number 2, female. Okay? That is for your X. Get it?
Yes, sir.
Yes, sir.
Okay. Third column, variable Y. Kaya ang isusulat ninyo doon, it's either against or in favor. If you like to code it, fine. Yung sex, pag male, 1. Pag female, 2. Okay, write the word. Yung pag sa Y, kung against, 1. Kung in favor, 2. Or just write the word. Okay? I repeat, column 1 is respondents, 1 to 33. Column 2, entry ng variable X, male or female. Column 3, variable Y, in favor or against. Okay? Afterwards, transpose the data to a coefficient matrix like this. It uses 4 cells, A, B, C, D. Cell A constitute the male respondents who express that they are against death penalty. Cell B would be female respondents who are against the death penalty. Cell C would be male respondents in favor of death penalty. And cell D would be female respondents in favor of death penalty. Tapos, summarize ninyo. Get the sum. A plus B, this column. And then C plus D, this column. A plus C for this column. And B plus D for this column. Why? Why do we have to do it? Kasi the formula calls for ito. The Phi coefficient is computed using AD. So you can see that in the table kanina, no? Minus BC all over the square root of A plus B times C plus D times A plus C and B plus D. Kindly look at the table kanina, this one. Kindly look at this table. Sorry. Ayan yung entry, ganyan, ano? Respondent, tapos sex, tapos opinion. Afterwards, ito yung final. Sinamarize natin. In other words, out of 33 respondents, 10 male respondents were against death penalty. No? Only 6 are in favor. A total of 16 male respondents. Out of 17 female respondents, 5. Only 5 are against. And 12 are in favor. Okay? In other words, considering both male and female respondents, 15 are against, 18 are in favor for a total of 33. When you get this summary of statistics, the next is a very easy activity. Substitute. What is A? Yung frequency ng A, nakalagay doon 10. Can you follow? Cell A, you have 10. All right? Hello? Can you follow? You look at the table, no? Nasundan niyo ba? Ulitin natin. Ayun, no? Ang A, 10. Okay? O kaya here, makita nyo, 10 times 12. And then 5 times 6. The denominator, A plus B is 15. C plus D is 18, A plus C is 16, and B plus D is 17. If you solve for it, you will get a correlation coefficient equal to 0.33. So that's how you do it when you are dealing with data in the strength of categorical or nominal measurements that are dichotomous. And then you interpret, and you have to be guided by the same rule natin. Let me go to the last test, no? Unless and then I will entertain your questions later. Okay, so do you see something on screen? Chi-square test of independence?
No.
Wala pa po, sir.
You don't see anything? Okay, mag-share kami ng screen.
Hi, Dr. Ray, sir.
Yes, Dr. Nuki.
Time check, it's already 3:16.
What do you say? Can we finish the chi-square and then we end?
Sige po, sir. But if it is still lengthy, sir, baka po magkaroon lang ng information overload yung ating mga estudyante. Baka po, ano.
Sige.
Kasi kanina umaga, they already had research lecture with me also.
Okay.
Baka sumakit na rin ulo nila, sir.
Fine. That's a good consideration.
Yeah.
I'm not privy to what happened this morning. No? So ganito na lang gawin natin. I'll find time if we can, kasi itong chi-square test, kanina yung Phi coefficient is very powerful, but the usefulness is limited to working with data in the strength of categorical pero dichotomous. What I'm saying is, what if you are dealing with data that are categorical in character, but non-dichotomous, like you have 4 columns, 5 columns, or 10 columns. No? So hindi pwedeng gamitin yung 5. The more reliable, or the more useful will be the use of chi-square test and Kramer's B. So gawin na lang natin, tamang si Dr. Nuki, baka may information overload na mga estudyante. We will just, I'll spend time discussing this next meeting before I proceed to the last lesson, which is regression analysis. So may I turn over the floor to Dr. Nuki for some final questions or reactions from the students?
Yeah, all right. May we ask? We will now entertain questions from our students. Of course, this is not just the first time that Dr. Ray will be delivering a lecture. And this afternoon has been very fruitful and informative afternoon. Kasi kita nyo naman, talagang maraming na-share si Dr. Ray sa inyo. But of course, we are considering that you are also attended my class this morning. Sabi ko kay Dr. Ray, baka information overload na sila.
That's correct.
And then they are also preparing their chapter 1.
Oh, really?
So we still have more time next Saturday. If you want, we can start as early as 1 o'clock so that there will be more time for discussion. And I'd like to remind the group also that you are very lucky because you now have the taste of the real statistics, no? Because this is the actual computations that are really employed in statistics. But on the other hand, you will also experience the other side of statistics using the software. No? So pinaparamdam lang namin sa inyo yung both worlds, the manual and the technological part of statistics, because maganda namang ma-experience nyo yung parehas. And this is the original statistics, the orig. Before talaga ganito yung computations natin. And I think sa mga nagtuturo ng stat, malaking tulong to sa inyo kasi kahit sa basic education, nagtuturo pa rin ng manual, di ba, sir?
Yes.
Statistics, yeah, all right. So,
although Dr. Noki, I like to emphasize to the group that we are we are trying to espouse the use of technology. Dapat mag-SPSS sila.
All right.
There are classroom-based researches that may require, so dapat alam din nila yung manual computation.
That's right. And it's a very good background that they know the manual computation, so that when they get to see the output of SPSS, hindi sila magugulat kung bakit at least alam nila kung paano na-derive yun. Kaya lang this time, using the technology nga lang. So, are there any questions before we thank Dr. Ray for his time and effort in explaining the inferential statistics and giving us a background also of descriptive statistics a while back? Any question? Silence means none.
Dr. Noki, if they don't have questions, may I ask one myself? No? Since this is not the first time that I will be facing the group or meeting the group, can I ask the group for some comments regarding the speed? Do they find the sharing very fast or very slow para makapag-adjust ako next time? Regarding the delivery, yung speed ng...
Yeah. So any comment about the delivery? Anyone?
Is it very fast? Is it very slow? Or just okay with you?
Hi, sir.
Just okay po.
Just okay. Thank you very much.
Yeah.
All right. Any further suggestions that you want me to, anything that you want me to improve later on? Next Saturday, for example? So, okay lang sa inyo lahat, ha? Yung speed, delivery of the lessons.
I think they're happy, sir.
Okay.
Silence means happiness.
Sige. So, at least for today, let me thank all of you, particularly Dr. Nuki.
And of course, we would like to appreciate the presence of the Dean of Mekawain College Graduate School.
Is Dr. Francis around?
Yes.
Oh, yes.
He's
Hi,
here.
Dr. Francis.
Hi, sir. Yes, sir. I'm here. I keep on looking at you. There's no difference, actually. I'm so happy. I'm so glad to see you very sound and healthy, sir.
Thank you.
Right.
Hindi ba halatang na-opera?
Ay, wala pong indication that you have undergone an operation.
Thank you very much, Dr. Francis.
Yeah. And Dr. Ray, I'd like to tell you also that these students are very lucky because this lecture is recorded as per kanina when they agreed that it will be recorded. I recorded it so that next time when they would like to go back on some topics that they missed, for example, that they did not understand well, they can review your lecture.
Yes.
So this is recorded and will be uploaded very soon. If not tonight, siguro tomorrow.
Thank you very much, Dr. Nuki, and thank you very much to all the students. And Dr. Francis, nice to see you again.
So we will see each other again next Saturday because next
Okay.
Saturday, there will be another lecture coming from Dr. Reynaldo Cruz. So with that, we will call it a day. It's been a long day for everybody who are enrolled in research and statistics. It's been a long day and good luck to all of you. And we will call it a day. Thank you so much.
Thank you po, Dr.
Thank you po, Dr. Ray.
Congratulations, sir. Congratulations, Dr. Nuki and Dr. Ray. On behalf of Mekawain College, we really appreciate the efforts that you have given to us. No, we know na this is quite different. We are so comfortable with face-to-face, but you really delivered the topics very exemplary. Thank you po.
Very good. You deserve a well round of applause, Dr. Ray. Kaya lang di lang marinig.
Thank you.
Thank you, sir.
See all of you next week.
Yeah. And for those who are in the thesis writing, seminar, research seminar, according to Dean Daes, you will see also Dr. Ray paneling in the defense, acting as a chairman in the defense. You can also consult him in your statistical computations as per the Dean of the Graduate School of Meycauayan College.
Yes, sir. Our defense or our defenses, future defenses would be incomplete if Dr. Nuki will not be there. And Dr. Ray is not there. Okay.
All right. So it's been a long day, and thank you so much to everyone. I hope everyone who is present here, learned a lot from our discussions. Thank you, and see you again next Saturday for another fruitful discussion. Bye-bye, everyone, and have a good day.
Thank you po. Thank you po.
Keep safe.
Thank you po,
Thank you.
Dr.
Ingat po.
Dr. Dice, maraming
Sir Ray,
salamat.
thank you po.
Thank you
Sir
po.
Ray, thank you, Sir Dice. Thank you.
Dr. Ray, maraming salamat.
Thank
Tatay
you,
Ray,
Dr. Nuki.
maraming
Thank you,
salamat.
Dr. Francis. Thank you.
Thank you, sir.